Hey everyone, and welcome to this explainer from the DS Perera IT Academy. Today we're diving deep into a really crucial part of Java, class design. Now, if you're an IT student, you know that getting this right, understanding how to build classes properly, is pretty much the foundation for everything else in object-oriented programming. So we're going to break it all down, piece by piece, not just what these concepts are, but why they matter. Ready? Let's get started.
So, here's our game plan. First, we'll tackle the this keyword, super important for how objects manage themselves. Then we'll jump into static members, which are all about the class itself. After that, we'll get into initializer blocks, which is another cool way to set up our objects. And to wrap it all up, we'll do a quick summary and even look at some exam tips to make sure you're fully prepared. All right, first up, the this keyword. It might seem like a tiny little word, but it's a massive concept in object-oriented programming. It's basically how an object can refer to itself from inside its own code. It sounds simple, but it's incredibly powerful. Let's dig in and see exactly how it works. Okay, so what exactly is this? Well, in simple terms, it's a reference to the current instance of the class. Think of it as an object's way of saying me or myself inside its own code. Now let's break that down in more detail. අපි මේක සිංහලෙන් සරලව තේරුම් ගමු. හිතන්න ක්ලාස් එකක් කියන්නේ උදාහරණයක් විදිහට මිනිසා කියන සංකල්පය වගේ බ්ලූප්‍රින්ට් එකක්. එහෙම නැත්නම් සලස්මක්. මේ මිනිසා කියන ක්ලාස් එකෙන් අපිට ඔබ්ජෙක්ට්ස් හදන්න පුළුවන්. හරියට කමල්, නිමල්, සුනිල් වගේ. දැන් කමල්ට එයා ගැනම කතා කරන්න ඕන වුණොත් එයා මම කියන වචනය පාවිච්චි කරනවා. නිමල්ට එයා ගැන කතා කරන්න ඕන වුණොත් එයාත් මම කියන වචනයමයි පාවිච්චි කරන්නේ. මෙතනදී මම කියන වචනේ තේරුම කතා කරන කියලා අනුව වෙනස් වෙනවා. Java වල this keyword එකත් හරියට මේ වගේ තමයි වැඩ කරන්නේ. ක්ලාස් එකක් ඇතුලේ ලියන කෝඩ් එකකදී ඒ වෙලාවේ වැඩ කරන ඔබ්ජෙක්ට් එකට, ඒ කියන්නේ current object එකට තමන්වම හඳුන්වගන්න පාවිච්චි කරන reference එක තමයි this කියන්නේ.
Now, this is the really important part to get. This isn't static. It's dynamic. What that means is its value actually changes depending on which object is running the code at that moment. So, if an object called monster1 calls a method, then inside that method, this refers to monster1. But if monster2 calls that exact same method, this suddenly points to monster2. Let's explore this with our monster example. Api hitamu, monster kina classic in api monster1, monster2, sa monster3 kiela, objects thunak hadanawa. Hema object igatema age saha name kina, tamuntama aveneka, instance variables tinawa. Done. Object akak hadana constructor ke athule, this.age equals age kila line akak thinoa. Api monster1 equals new monster20, 1 kila object akak hadana korda, constructor ke athule, this keyword again at daswenne, monster1 kian object eka. Ekiane, me hadamin pavatina, monster1 ge age ekada, 20 kiana age dan kiana eka. Evagema, api monster2 equals new monster30, m2 kila headworth. Eurave constructor ke atale, this keyword again, monster2 kiana object ekatamai refer wenne. Ifin, this kiani static, ekiani nieta dakneve, dynamic, ekiani gatika referencekak. Eke hemovelima yomovenne, kodika runkurina e muhatene object ekata.
So, one of the most common and practical uses for this is to solve a tricky problem called variable shadowing. This is something that trips up a lot of new programmers. It happens when an instance variable, that's the one that belongs to the whole object, has the exact same name as a local variable, like a parameter in a method. As you can see in the table, we absolutely need a way to tell them apart. Let's imagine a constructor for our monster. Hitana, constructor ekira parameter ekak vidira ent age kilenwa. Make a local variable ekak, mokada eka, pavitinne constructor ke atule vitarai. Evagema class eka atulet, private int age kila instance variable ekak tiyanwa. Make a object ekada aiti ekak. Then nam dekama ekai. Api constructor ke atule, age equals age kila liwot, Java compiler ekada tirene na, api khata karanne mona age eka gyanada kila. Eka hitanne api local variable ekata ekema agya apahu assign karnawa kila. Make it tamai variable shadowing kyanne. ඉතින් object එකට අයිති instance variable එකට අගයක් දෙන්න නම් අපි compiler එකට පැහැදිලිව කියන්න ඕනේ මට ඕනේ මේ object එකට අයිති age එක කියලා. අන්න ඒකට තමයි අපි this.age කියලා පාවිච්චි කරන්නේ. This.age කිව්වම එකෙන් instance variable එකත් this නැතුව කියන age කිව්වම එකෙන් local variable එකත් අදහස් වෙනවා. Okay, here's another really powerful way to use this. It's for something called constructor chaining. Basically, you use this with parentheses, almost like you're calling a method, to have one constructor call another constructor inside the very same class. It's an absolutely fantastic way to reuse your code and keep things clean. Make a programming walidi code duplication. Ekianne ekama kodege nevata liyaneka adukaraganna pavichi karana harima priyojanavat technikayak. Hitanna අපේ monster class එකේ constructors දෙකක් තියෙනවා. එකක් කිසිම parameter එකක් ගන්නෙ නෑ default constructor. අනිත් එකේ age සහ name කියන parameters ගන්නවා. Then parameter නැති constructor එක call කරලා object එකක් හදනකොට අපිට ඕනේ default විදියට age එක දය සහ name එක A1 කියලා set වෙන්න. එක ක්‍රමයක් තමයි default constructor එක ඇතුළත initialization code එක ලියන එක. හැබැයි එතකොට එකම code එක දෙපාරක් ලියවනවා. ඒ වෙනුවට අපිට පුළුවන් default constructor එක ඇතුළේ ඉඳලා this 10,a1 කියන parameters ගන්න constructor එක call කරන්න. එතකොට initialization එක සිද්ධ වෙන්නේ එක ප්‍රමේක විතරයි. මෙතන තියෙන වැදගත්ම නීතිය තමයි this call එක හැම වෙලේම constructor එකක පළවෙනි statement එක. ඒ කියන්නේ පළවෙනි පියලිය වෙන්නම ඕන.
Okay, so let's trace the exact flow of what's happening with constructor chaining. It's super important to understand the order of events. Step 1, the default constructor, public monster, gets called. Step 2, the very first thing inside it is that this 10a1 call. This immediately passes control over to the other constructor, the one that takes parameters. And finally, step 3, that parameterized constructor runs, does all the heavy lifting of initializing the variables, and then we're done. Now let's get into the nitty-gritty. අපි මේ ක්‍රියාවලිය පියවරෙන් පියවර බලමු. පියවර 1, program එකේදී monster my monster equals new monster කියලා code එකක් run වෙනවා. එතකොට default constructor එක. ඒ කියන්නේ public monster කියන එක call වෙනවා. පියවර 2, a constructor එක අතුරට ගිය ගමන් Java virtual machine JVM එක දකිනවා this 10a1 කියලා statement එකක්. මේ statement එකෙන් program control එක ඉතුරින් public monster int age a string name කියන constructor එකට මාරු වෙනවා. ඒ යනකොට 10 සහ a1 කියන ආගයන් parameters විදියට අරගෙන යනවා. පියවර 3, then parameterized constructor execute වෙනවා. ඒක ඇතුළත තියෙන this stage equals age සහ this name equals name කියන lines වලින් object එක instance variables වලට අරගෙන ආපු ආගයන් assign වෙනවා. මේක ඉවර වුණාම control එක ආපු default constructor එක යනවා. එතන ඊතර code එකක් තියෙනවා run කරලා object එක හදලා ඉවර කරනවා.
So we've seen this used for variables and constructors, but believe it or not, it has a few other tricks up its sleeve. You can also use it to explicitly call a method, pass the current object as a parameter to another method, or even return the current object from a method. Let's break these down real quick. First, calling a method. Sometimes, just for clarity, you might write this.myMethod instead of just my method. It does the same thing, but it makes it super obvious that you're calling a method belonging to this specific object. Second, passing as a parameter. This is really useful. Imagine an object needs to tell another object, hey, here I am. For example, a monster object could pass a reference to itself to a warrior object by calling a method like warrior.setMonster this. This is how you build relationships between objects. And third, returning the current instance. A method can literally return the object it belongs to by using return this. You see this a lot in a design pattern called a builder, or for method chaining, which lets you call a bunch of methods on the same object in one clean line of code.
All right, let's switch gears completely. We've been talking all about individual objects and how they use this to refer to themselves. Now we're going to talk about static members. The core idea here is a complete flip. Static variables and methods don't belong to any single object. Instead, they belong to the class itself as a whole. So when you stick that static keyword in front of a variable or a method, you're making a big statement. You're saying, this doesn't belong to any one object. It belongs to the entire class. And here's the most important consequence of that. There is only one single copy of a static member in memory. It doesn't matter if you create one object, 100 objects, or 1,000 objects, they all share that one copy. That's why we often call them class members. අපි කලින් කතා කරපු instance variables වලදී අපි class එකේ object එකක් හදන හැම පාරම ඒ variable එකේ අලුත් copy එකක් හැදෙනවා. හැබැයි අපි variable එකක් static විදිහට හැදුවොත් අපි ඒ class එකෙන් objects 10ක් හැදුවත් 1000ක් හැදුවත් memory එකේ ඒ static variable එකේ තියෙන එකම එක copy එකයි. හිතන්න පන්තියක ළමයි ගොඩක් ඉන්නවා. හැම ළමයෙක්ටම වෙනම පොතක් instance variable තියෙනවා. හැබැයි පන්තියේ තියෙන්නේ එකම එක කළු ලෑල්ලයි static variable. එක ළමයෙක් කළු ලෑල්ලේ යමක් ලියුවොත් ඒක අනිත් හැමෝටම පේනවා. Static variables වැඩ කරල්ලෙත් අන්න ඒ විදියට. This diagram makes the difference so clear. On one side, you've got the instance variable age. Notice how each monster has its very own copy with its own value. But on the other side, look at monster count. All three of those monster objects are pointing to the exact same single shared variable. That means if one monster changes it, the others will see that change instantly. මේ රූප සටහනෙන් වෙනස හරිම පැහැදිලි. age කියන්නේ instance variable එකක් නිසා ඒක object එකකේ age එක වෙනස් කළාට අනිත් object වල age එකට ඒක බලපාන්නේ නෑ.
නමුත් monster count කියන්නේ static variable එක. ඒක class එකටම පොදුයි. ඒ නිසා object තුනටම තියෙන්නේ එකම monster count එක. ඒකේ අගය 3 නම් monster 1 හරහා බැලුවත් monster 2 හරහා බැලුවත් පේන්නේ එකම අගය 3. අපි යම් විදිහකින් monster 1 පාවිච්චි කළා monster count එක 4 කළා කියමු. එතකොට monster 2 සහ monster 3 හරහා බැලුවත් monster count එකේ අගය 4 වෙලා පෙනෙයි. මොකද හැමෝම බලන්නේ memory එකේ තියෙන එකම තැන.
Let's look at a really practical code example using this bicycle class. Our goal here is simple. We want to count how many bicycle objects we ever create. The perfect tool for this is a static variable, which we'll call num of bicycles, and we'll start it off at 0. The logic is pretty straightforward. Api classic etule, private static int, num of bicycles equals 0. Kila static variable ekak havenoa. Make a classic item a podu counter ekak. Ilang ita, classic e constructor ek atule, api era static counter eka ekikin verikaranoa. Num of bicycles plus plus. Itin alut bicycle object ekak havena hama parama mulu bicycle ganana update venua. Apita peluang e counter eke agera alutin hadapu bicycle eke unique ek ID activitiera dena. Me mulu ganana denagana api public static int get number of bicycles kill static method ekak havenoa. Me awage static method ekak call karane object ekak haranui bicycle.get number of bicycles kilo classic anama pavichikarala.
You know, a perfect real-world example of static methods that you've probably already used is Java's built-in math class. When you want to find the minimum of two numbers, you don't create a new math object, right? Of course not. You just call the method directly on the class, math.min. This works because the operation doesn't depend on any specific object's data. It's a pure utility function. Java vela math class etiana math.max, math.squared, math.random waget method okoma static. හිතන්න 10 සහ 20 කියන සංඛ්‍යා දෙකෙන් අඩුම සංඛ්‍යාව හොයන්න ඔබ්ජෙක්ට් එකක කිසිම data එකක් instance variables අවශ්‍ය වෙන්නේ නැහැ. ඒක input දෙකක් අරගෙන output එකක් දෙන සරල ක්‍රියාවලියක්. මේ වගේ ඔබ්ජෙක්ට් එකක state එක මත රඳ නොපවතන පොදුවේ පාවිච්චි කරන්න පුළුවන් functions හදන්න static methods ඊටම සුදුසුයි. ඒ නිසා තමයි අපි math.min 1020 කියලා class name එකෙන් කෙලින්ම call කරන්නේ.
Now, there are two absolutely critical rules you have to remember when you're working in a static context, like inside a static method. First, a static method cannot directly touch a non-static instance variable. Why? Well, it's simple. The static method belongs to the class, not one specific object, so it would have no idea which object's variable to use. Second, for the same reason, you can't use the this keyword. This means the current object. But in a static context, there is no current object. 1. Static contexts cannot access non-static members. Hitonna api bicycle.get number of bicycles kina static method ekatoli. Speed kina instance variable like access kurana hedua kiala. Speed kina eka hama bicycle object ekadama wena venametiana. Static method eka call kurane classic anamen. Etokura Java compiler ekada prashnya kenoa wayata oni mono bicycle eke speed ekada. Ave lave bicycle objects of siak memory ekatiana piluin. Enisa kisima object ekaraka sambandek naki in a static context eka karkara. Object ekaraka IT non-static member ek access karandan eka tarkon kula veredi. 2. Static contexts cannot use this. I'll be calling eganagata this keyword ekanada hasvenda the current object kiela. Static context eka kisima object ekara IT net. It's in current object kanahi teneka this keyword eka pavati karaneka tedomakneti verak.
Okay, let's move on to our final technical topic for today. Initializer blocks. Think of these as special blocks of code that run when an object is being created. They give us yet another way to set up an object's initial state, working right alongside our constructors. First up, we have the instance initializer block, or IIB for short. You can spot it easily. It's just a set of curly braces. Curly braces sitting directly inside the class, but outside of any method. The key thing to know is that this code runs every single time a new object is created, and it always runs right before the constructor. So what's it for? It's perfect for handling any setup logic that's common to all of your class's constructors. Hitanna, a bit of classic constructors throck tienwa. Eight the mona constructor eka call collad, object eka yam variable eka ekama ageking initialize when no oni kiela. A code line eka constructors 3 miliano of venuata, a bit of bluan eka IIB eka katale, eka parak liana. Making code duplication eka aduela, program eka nodoctaker in the lacy wenwa. Make a non-static block, kill it what hundananoa, mukara make a watakarane object eka kadanakota. And just like the IIB, we also have a static initializer block. You can tell it apart by the static keyword right before the curly braces. This block has one specific job, to initialize the static variables of a class. And the most important thing to remember here is that it runs only once, the very first time the class is loaded into memory by the JVM, and never again.
මේකේ ප්‍රධානම කාර්යය තමයි classic static variables වලට ආරම්භක අගයන් දෙන එක. විශේෂයෙන්ම initialization එක සරල assignment එකකට වඩා සංකීර්ණ නම් උදාහරණයක් විදිහට database එකෙන් අගයක් load කරගන්න ඕන නම් මේ static block එක පාවිච්චි කරනවා. class එක memory එකට load කරගන්න පළවෙනි වතාවේදී විතරක් මේ block එක run වෙනවා. ඊට පස්සේ අපි මේ class එකෙන් object කීයක් හැදුවත් ආයිමත් run වෙන්නේ නැහැ.
Okay, this brings us to a really important concept, one that often shows up on exams: the precise order of execution when you create a new object. This order is non-negotiable, it's always the same. Static blocks run first, then the instance blocks run, and finally the constructor runs. May execution order eka modika tiagenema itama vergat. Pure ake, static initializer blocks. Classica memory ekata load karna pulveni vidavedi the tarak, classica tiena static block a coma, eva lila tiena pali velit, execute weno. Pure 2, instance initializer blocks. New keyword ika kalkarnata passa, a classica tiena instance initializer block IIB a coma, eva lila tiena pali velit, execute veno. Pure 3, the constructor. Antamoma api kalkarapu constructor eka, execute weno. Eakiani api classicinen polyveni object eka hadanakodo, puilavitamai, static block, instance block, constructor. Habai api a classic nim deveni object ege hadanakodo, static block eka I run venene. Etaquota puilever veni, instance block, constructor.
Phew, okay. We have covered a ton of ground. So let's shift into our final section now and pull everything we've learned together. This is all about summarizing the key points and making sure you're totally ready for any potential exam questions on these topics. All right, let's do a quick fire round of the most important concepts we've covered today. Hari, api me lecture ke iganagata pradhanama karna tika mata karagamu. This keyword, remember, this always refers to the current object instance. Its main jobs are solving variable shadowing and constructor chaining. Static keyword. Anything declared static belongs to the class, not the object. There's only one copy and it's shared by all objects. Instance initializer block, IIB. This runs every time an object is created right before the constructor. Static initializer block. This runs only once, the very first time the class is loaded into memory. Execution order, and you have to know this order. Static block first, then the instance block, and finally the constructor.
So here's a super common type of exam question you might see. To nail this answer, you'd need to define both types of variables. You'd have to talk about memory allocation, one copy per object versus one copy per class, and discuss their scope. And then the key is to provide a clean, simple code example, just like our bicycle class, to really prove you understand it.
Here's another classic. For this question, you'd start by defining constructor chaining as one constructor calling another using this chaining. Then you'd explain its main purpose is to reduce code duplication and centralize your setup logic, especially when you have default values you want to use. And finally, you'd write a simple class that shows a default constructor calling a parameterized one.
And one final potential question for you. For this, you have to be precise. A perfect answer would clearly state the sequence, static blocks first, and you must mention they run only once when the class is first loaded. That's followed by the instance blocks, which run for every single new object. And finally, the constructor itself runs. If you really want to impress, mention what happens differently for the second object creation, that the static block doesn't run again.
You know, to wrap everything up and make sure these ideas really stick, let's use one last simple analogy. Just think of a car factory. The class is the master blueprint for a car, let's say a Toyota Camry. Now, static variables are like the factory-wide data. For example, the total number of Camrys produced for the entire day. That's a single number, a single piece of info that's shared across the whole factory. Instance variables, on the other hand, are the details that are unique to each individual car rolling off the line. Its specific vehicle identification number, or VIN, its color, its engine number. Every car has its own set of these. And the constructor? Well, that's the assembly line itself, the actual process that takes the blueprint and builds one specific car with all its unique features. I really hope this explainer has made these core Java concepts much clearer for you. Make sure to review the material, try out the code examples for yourself, and you'll be in great shape. Good luck!